So I'm glad India did not land in the same place everybody else has landed on the moon. That's not interesting. You chose a place where no one has landed before, and that's the South Polar region of the moon.
Get ready for a lunar revelation unlike any other. When Neil deGrasse Tyson shared details about India's astonishing discovery on the moon, the world paid attention.
They're targeting the South Pole to land to check and verify that there's water there inside those craters.
This wasn't just any celestial news. It was a discovery that reshaped our understanding of Earth's satellites. Dive in to learn what India discovered and why it's causing such cosmic commotion. In the annals of space exploration, Russia's first contact on the moon marks certain moments that leave an indelible imprint on our collective consciousness. Such a milestone occurred in early 1966 when the world witnessed the remarkable achievement of Luna 9, a Russian mission that became the first to achieve a soft landing on the moon. It didn't just land safely, it also sent back stunning panoramic images of our nearest celestial neighbor. Luna 9 wasn't an ordinary spacecraft. It resembled a spherical capsule, and its design was innovative and strategic. It weighed 99 kilograms and measured 58 centimeters in diameter. The craft was equipped with 4 petals that, upon Luna 9's successful landing, unfolded. Their purpose was twofold. First, to stabilize the craft, ensuring it remained upright, and second, to reveal the vital instruments it carried. Among its payload was a radio system designed for communication, a set of state-of-the-art solid-state radiation detectors, and a crucial thermal control system to handle temperature fluctuations. Perhaps the most captivating of all its instruments was its television camera, strategically mounted on a platform capable of rotating and scanning the vast lunar horizon. As the world waited, Luna 9 began its operations and did not disappoint. The lunar views it captured were nothing short of fascinating, showing a terrain of stark contrasts, rugged craters juxtaposed against rolling hills, a landscape untouched by human activity. These images were so captivating that the Jodrell Bank Observatory in England received them and soon made headlines, appearing in the Daily Express newspaper. However, Luna 9's mission wasn't just about capturing visuals. The spacecraft undertook critical scientific research. It meticulously recorded lunar temperatures, noting extremes from a frigid -153 degrees Celsius at night to a scorching +123 degrees Celsius during the day. The measurements it took revealed the moon's nearly non-existent atmosphere, with a pressure less than 1/billionth of what we experience on Earth. Luna 9 also reported on radiation levels, revealing a dose of about 30 roentgens per day. Luna 9 didn't stop at observation. It interacted with the lunar soil, performing a rudimentary soil mechanics experiment. The craft used a rod to press against the lunar regolith, and the results were enlightening. The regolith exhibited a crush resistance of at least 0.4 kilograms per square centimeter. This crucial finding indicated that the lunar surface was sturdy enough to support the weight of future landers and even rovers. But as with all good things, Luna 9's mission had an endpoint. After a relatively short duration of about 3 days on the moon, the craft's batteries ran out. Nevertheless, in its brief time, it managed to transmit a total of 8 fascinating images and several batches of invaluable data. Luna 9's remarkable journey was soon followed by Luna 13, which landed later that year on December 24th. This subsequent mission carried forward the legacy, conducting similar experiments and deepening our knowledge of the moon. The unforgettable journey to the moon by Apollo 11 and then in 1969 unfolded a monumental event that forever changed our perception of space and our place in the universe. This remarkable journey took its first steps on July 16th when the Apollo 11 mission was launched from the Kennedy Space Center in Florida. Part of the ambitious Apollo program, the main goal of the mission was to transport humans to the moon's surface and ensure their safe return to Earth. Apollo 11 is the first human attempt to demonstrate the capability to go to the moon, land there, and return to Earth. This task was entrusted to 3 extraordinary astronauts: Neil Armstrong, the mission commander and the pioneer who would forever be remembered as the first human to step on the moon; Edwin "Buzz" Aldrin, the lunar module pilot who followed Armstrong's historic steps; and Michael Collins, who played the pivotal role of orbiting the moon in the command module while his colleagues embarked on their lunar exploration. A marvel of engineering and innovation, Apollo 11 was composed of 3 crucial segments: the command module, named Columbia, and the service module and the lunar module, nicknamed Eagle. The command module was essential, as it was the only component designated to make the journey back to Earth, safeguarding the astronauts within. Meanwhile, the service module was like the lifeboat of the mission, ensuring a constant supply of energy, oxygen, water, and propulsion to Columbia. The lunar module, with its two-stage design, was responsible for transporting Armstrong and Aldrin from their lunar orbit to the enigmatic lunar surface and, subsequently, back to the command module. The journey of Apollo 11 spanned approximately 8 days, a period filled with anticipation, wonder, and revolutionary discoveries. After its departure from Earth, the spacecraft made its rendezvous with lunar orbit on July 19th. This set the stage for the next phase of the mission. On July 20th, Armstrong and Aldrin aboard the lunar module began their descent, eventually touching down on the serene Sea of Tranquility, better known as the Sea of Tranquility. The world held its breath as Armstrong emerged from the module and declared, "This is one small step for man, a giant leap for mankind," as he planted his foot on the lunar surface. Aldrin joined him shortly after, and the duo spent about 2 hours conducting experiments, collecting invaluable samples, planting the American flag, and setting up scientific instruments. During this, they even communicated with President Richard Nixon in a memorable radio-telephone exchange. While these activities were underway, Collins diligently continued his orbit around the Moon in the command module. His tasks involved conducting his own set of experiments and capturing photographic evidence of the lunar surface. After Armstrong and Aldrin concluded their lunar tasks, their next challenge was to rendezvous with Collins. This meeting occurred smoothly on July 21st. After this, the astronauts bid farewell to the lunar module, established their course out of lunar orbit, and began their journey back to Earth, culminating in a successful splashdown in the Pacific Ocean on July 24th. The achievements of Apollo 11 extended beyond the tangible. Scientists gained critical insights from the mission's data. It was discovered that the Moon possessed a tenuous atmosphere, composed primarily of helium, neon, and argon. The lunar landscape was dominated by regolith, a layer of fine dust formed by impacts of micrometeorites over millennia. The absence of a global magnetic field on the Moon intrigued scientists, although some areas exhibited localized magnetic peculiarities. Although predominantly arid, there were indications of water ice lurking in the perpetually shadowed craters of the Moon. The most revealing was the age of the Moon, estimated at about 4.5 billion years, hinting at its formation due to a colossal collision between Earth and another celestial entity. In 2023, the world watched as India wrote a new chapter in space exploration with its Chandrayaan 3 mission. This mission was unique not only for India but for global space exploration efforts because it aimed to land near the elusive South Pole of the Moon, a region shrouded in mystery. The South Pole held promises of significant scientific revelations and presented intricate challenges. The Chandrayaan 3 mission was intricate in its design and ambition. It comprised 3 key components, each dedicated to performing distinct but interrelated tasks. The orbiter was the watchful eye in the sky, equipped with 8 cutting-edge scientific instruments. Its job was to observe and scrutinize the lunar surface and atmosphere from an orderly circular orbit, about 100 kilometers above the Moon. Accompanying the orbiter was the landing module, named Vikram in honor of Dr. Vikram Sarabhai, the visionary founder of the Indian Space Research Organization, also known as ISRO. Vikram was more than just a symbolic tribute. It was a workhorse equipped with 4 essential instruments. These tools were designed to record data on temperature variations, seismic activities, plasma density, and surface composition near its designated landing site. Last but certainly not least was Pragyan, a rover whose name is rooted in the Sanskrit word for wisdom. True to its name, Pragyan was a repository of knowledge on wheels as it meandered over the lunar terrain. Its 2 onboard instruments worked tirelessly to uncover details about the Moon's mineralogy and elemental richness of the soil. The journey to the Moon began on July 14, 2023. The skies over the Satish Dhawan Space Center in Sriharikota, India, roared to life as the reliable Polar Satellite Launch Vehicle, also known as the PSLV rocket, carried Chandrayaan 3 on its maiden voyage. But the journey was not direct. The spacecraft engaged in a delicate dance around Earth for over a week, gaining time and building momentum. On July 21, 2023, Chandrayaan 3 embarked on the next stage of its journey. In a calculated move, the spacecraft executed a trans-lunar injection maneuver, positioning itself to be captured by the Moon's gravitational pull. This propelled it into an elliptical orbit around our celestial neighbor. But the team at ISRO was not yet done fine-tuning its trajectory. Over the following weeks, Through a series of precisely executed orbit-raising and lowering maneuvers, they meticulously maneuvered Chandrayaan-3. Their goal was to position it in an optimal circular orbit, approximately 100 kilometers from the lunar surface. By August 19, 2023, this goal had been achieved. The descent of Vikram and the lunar expedition of Pragyan. Following the meticulous dance of the Chandrayaan-3 orbiter in the embrace of the Moon, August 23, 2023, marked the moment for the landing module Vikram to undertake its ambitious descent towards the lunar South Pole. Separating from its mother orbiter, Vikram was in position to face the challenge of descending toward a celestial body, a challenge not unlike balancing on a tightrope. Descending from space to a celestial body is no small feat. Vikram had the critical task of reducing its speed, which was a dizzying 1.68 kilometers per second using its built-in thrusters. The landing module systematically reduced this speed to almost a standstill. But the task was not just about speed. As Vikram approached the Moon, it had to adjust its trajectory and attitude with immense precision to dodge lunar obstacles and ensure it did not crash. Think of it like a pilot making last-minute adjustments during a landing, ensuring a safe touchdown for everyone on board. And Vikram did just that, nestling between two lunar craters, Simpelius N and Manzinus C. This particular region is known for its extreme temperatures, which can drop to a chilling -240 degrees Celsius, and where sunlight becomes a luxury that only occasionally adorns the terrain. Shortly after its grand landing, Vikram wasted no time. The landing module smoothly deployed its solar panels, like wings stretching after a long flight. It also extended its antennas, forming a communication bridge with the orbiter above and, by extension, with the researchers and scientists on Earth who eagerly awaited any data. But the expedition on the lunar surface was just beginning. After allowing a brief period for the lunar dust to settle, much like waiting for the dust to settle after a gust of wind here on Earth, the rover Pragyan received the green light. Emerging from Vikram's ramp, the rover stepped out like an explorer setting foot on an uncharted island. Pragyan had a fortnight, a single lunar day, to accomplish its objectives. Designed to travel up to half a kilometer from its parent landing module, the rover was a masterclass in autonomy. Cameras and sensors on board equipped Pragyan with the eyes and instincts to navigate the rugged and unpredictable lunar terrain, ensuring it did not stumble over obstacles or find itself stuck in a tricky spot. The economic exploration, India's mission, was not only the first to bravely step into the unexplored territory of the lunar South Pole, but it also did so with financial finesse that left many astounded. With a tight budget of just $74 million, Chandrayaan-3 was a testament to India's mastery in combining cost-effectiveness with advanced space innovation. To understand the financial aspect, let's delve into the numbers, as revealed by the then-president of ISRO, K. Sivan. The overall expenditure of the mission was 615 crore rupees, approximately $74 million. Within this, the expenditure for the landing module, rover, and propulsion module was about 215 crore rupees, while launch services incurred a cost of around 365 crore rupees. This efficient budget was even more commendable when viewed in the light of the previous Chandrayaan-2 mission, which, despite its failure to land in 2019, had a heftier budget of 978 crore rupees, or $96.5 million. When juxtaposed with other international lunar expeditions, the cost-effectiveness becomes strikingly evident. Russia's Luna 25 mission, which aimed at the same lunar South Pole but met with an unfortunate crash, had a budget touching $200 million. Then there was NASA's ambitious Viper rover project scheduled for 2024, projected to cost an astounding $433.5 million. Not far behind was China's Chang'e 4, which made its mark on the far side of the Moon in 2019, carrying a price tag of around $180 million. One might wonder what the secret behind the economic success of Chandrayaan-3 was. A significant part of the answer lay in the compact design of the mission. With the combined weight of the landing module and rover being only 1.4 tons, Chandrayaan-3 was considerably lighter than many of its international counterparts. A good benchmark would be NASA's Viper rover, which alone weighed about 1 ton. This strategically lightweight design reduced several associated costs, notably those linked with launch and fuel. But weight was not the only advantage. Chandrayaan-3's financial efficiency was also attributed to its prudent use of existing technology. India had at its disposal the GSLV Mk3, not only the nation's most robust rocket, but also one that had been deployed in several previous missions. Additionally, rather than starting from scratch, the landing module and rover for Chandrayaan-3 were adapted and enhanced from the designs of Chandrayaan-2. Triumph over trials. The Chandrayaan 3 mission was one for the history books, being India's third attempt to study the mysteries of the moon. However, each step of the journey was fraught with challenges, from takeoff to landing. First, there was the colossal task of the launch and achieving the correct lunar orbit. On a momentous day, August 15, 2023, the skies over the Satish Dhawan Space Center in Sriharikota roared with the power of the GSLV Mk3 rocket, propelling Chandrayaan 3 into space. Yet reaching the moon was more than just a matter of speed. It was about precision. The spacecraft had to perform a series of intricate maneuvers using both its thrusters and the gravitational forces of Earth and the Moon to situate itself in the desired lunar orbit. The importance of this precise placement cannot be underestimated. It was crucial to ensuring the perfect trajectory for the subsequent landing stages. The mission's ambition did not stop there. The goal was to step onto a place where no mission had been before: the lunar South Pole. Scientists were eager to explore this region, suspected of hiding water ice and other invaluable resources within its craters. But aiming for the unexplored South Pole meant facing a set of formidable challenges, including its rocky landscape, extreme temperature shifts, and potential communication barriers. The team behind Chandrayaan 3 had a monumental decision to make: pinpoint a landing site that balanced the need for sunlight, a stable surface for landing, and uninterrupted communication channels with Earth. When dawn broke on August 23, 2023, the world watched with excitement for what was to come: the 17 minutes of terror as described by the chief of ISRO, Somanath. In this tense window, the landing module, named Vikram, had the Herculean task of reducing its speed from a rapid 1.6 kilometers per second to practically a standstill before safely touching down on the moon, without real-time communication or human intervention. Vikram had to rely solely on its onboard systems to make vital decisions. It had to adjust its thrust, analyze the uneven lunar terrain, and land without mishaps. And in a triumphant display, Vikram did precisely that, subsequently paving the way for the rover, named Pragyan, to venture onto the lunar surface. The rover then had its own set of challenges, navigating the dusty and rugged lunar terrain, dodging obstacles, and ensuring a constant communication line. But the journey didn't end with a successful landing. The mission was against the clock, with just 14 Earth days, equivalent to one lunar day, to carry out its operations on the lunar surface. This tight schedule had the landing module and rover racing against time, conducting experiments, studying the lunar soil, and recording temperature variations, among other tasks. Moreover, they had the important responsibility of transmitting these valuable data back to Earth. The obstacles were many: extreme lunar temperatures that ranged from a chilling -180 degrees Celsius to a boiling 100 degrees Celsius, unpredictable communication blackouts, the constant threat of solar radiation, and the challenge of efficiently managing energy. Neil deGrasse Tyson hails India's lunar expeditions. In 2019, as India prepared its Chandrayaan 2 mission to leave a significant mark on the lunar landscape, Neil deGrasse Tyson expressed his enthusiasm and optimism for the mission. He shared his thoughts with the world, declaring that the Chandrayaan 2 mission is no small feat. It set out to bring India into a select club, making it the fourth nation to land softly on the moon, following in the footsteps of the US, Russia, and China. However, it distinguished itself by aiming to be the pioneer in exploring the lunar South Pole region. His words resonated with many who eagerly awaited the success of the mission. Yet, space exploration is full of uncertainties. The Chandrayaan 2 mission faced a heartbreaking moment when its landing module lost its link with Earth during its crucial descent phase, ultimately leading to its unfortunate crash on the moon. The world shared India's disappointment, but Tyson's voice resonated with encouragement and motivation. He wisely commented that space efforts are inherently challenging. It is this difficulty that adds value to the endeavor. A setback is not the end. It's a push to try again with renewed vigor. Fast forward to 2023, and India was ready to rewrite its lunar narrative. Armed with lessons from the past and an indomitable spirit, the nation launched Chandrayaan 3, and this time, the stars aligned. India achieved what had eluded it 4 years earlier: a successful landing near the elusive and unexplored South Pole of the Moon. As news of the triumphant landing spread, Tyson was among the first to praise India's resilience and laud its achievement. He spoke about how India had accomplished what it set out to do with the successful landing of Chandrayaan 3 in the unexplored vicinity of the lunar South Pole. India has carved out a unique niche. This is not just a victory for India, it is a victory for scientific curiosity and global progress. But what makes the south pole of the moon so special? Tyson, with his knack for breaking down complex scientific concepts, provided clarity. He shed light on the significance of the region, describing the south pole of the moon as akin to a gold mine for researchers. It houses craters that, wrapped in perpetual shadow, could harbor water ice, a vital ingredient for life and a potential source of rocket fuel. Then, in marked contrast, there are peaks bathed in constant sunlight, serving as potential centers for harvesting solar energy. Beyond these resources, the ancient rocks of the South Pole promise a wealth of knowledge, harboring clues about the moon and Earth's intertwined past. The journey of Chandrayaan-3 to the moon. A milestone of this mission was its dedication to investigating the presence and distribution of water and other essential substances on the moon, particularly near its south pole. What made this region so captivating? It harbored craters hidden forever from sunlight, potentially protecting water ice, a treasure for future expeditions and human settlements. In contrast, parts of the South Pole basked in sunlight for most of the lunar day, offering a center for energy and communication for lunar missions. With such an ambitious mission, the team had to be top-notch. Vikram, the landing module, housed a lunar surface thermometer, also known as LST. This device took temperature readings of the moon throughout the day, building a thermal map around the South Pole. Such data were crucial because regions with sufficiently low temperatures could be hiding water ice. Additionally, Vikram was equipped with a set of laser retroreflectors, also known as LRA. This ingenious tool bounced laser signals from orbiting spacecraft or Earth-based telescopes. This interaction was not just for communication, it allowed scientists to measure distances on the moon and delve into the mysteries of lunar gravity and its rotation. Then there was Pragyan, the rover, an explorer armed with cutting-edge tools. It carried a laser-induced breakdown spectroscopy device, also called EES, and an alpha particle X-ray spectrometer, also known as APXS. The ELIBS wielded a laser that could turn a minuscule amount of lunar soil into vapor and then analyze the emitted light to understand the soil's composition. On the other hand, the APX identified elements in the soil, from oxygen and magnesium to rarer elements like titanium and chromium. Together, they sought signs of water by detecting elements like hydrogen and carbon. But Pragyan was not just about soil and elements. It had eyes in the form of a stereo camera, which we can also call SCAM. This camera took high-resolution snapshots of the lunar landscape, aiding in navigation and detecting obstacles. More than that, it represented the surface in 3D, helping to identify the best spots for sample collection and in-depth analysis. The fruits of this mission were nothing less than extraordinary. Pragyan stumbled upon sulfur near the South Pole, an element not commonly found on the moon. This discovery ignited discussions. Could this mean the presence of water ice or other volatile substances nearby? Moreover, Pragyan had its sensors attuned to hydrogen, a telltale sign of water. Vikram also transmitted intriguing data. Temperatures around the South Pole ranged from a chilly -156 degrees Celsius at night to a scorching 121 degrees Celsius during the day. Such insights were fundamental to understanding how water ice and other resources could persist in these harsh conditions. The discoveries of Vikram and more. The landing module Vikram not only touched down on the lunar surface, it got to work immediately. Tasked with a series of scientific missions, Vikram was packed with equipment designed to probe the enigmatic nature of the moon. It monitored temperature, sensed seismic noises, measured plasma density, and even assessed the strength of the lunar magnetic field. As Vikram advanced on the moon, the propulsion module was busy in orbit, observing both the lunar landscape and Earth from a unique vantage point. Aside from producing detailed images of the lunar topography, it embarked on a mission to study the polarimetry of Earth's atmosphere. The purpose? To understand the scattering properties of our atmosphere and gain insights into atmospheric phenomena and climate. And as if these discoveries weren't exciting enough, the propulsion module sent back some truly notable images. One of these showed a potential lava tube near the Schrödinger crater. Why was this significant? Lava tubes, massive tunnel-like structures formed by flowing lava, are believed to offer protection from space radiation, temperature extremes, and impacts from micrometeorites. This makes them ideal candidates for future human habitats on the moon. With the discovery of this potential lava tube, the doors for human exploration and long-term habitation on the moon opened a bit wider. As we conclude, let's take a moment to appreciate the wonders of space exploration and India's monumental contribution to it. Neil deGrasse Tyson's focus on this discovery reminds us that the universe still harbors many mysteries waiting to be unraveled. Until the next celestial update,